Welcome to Study Loop.
So if the lens power is negative, that means we have a diverging lens. So for negative power, we have a diverging lens. And since it's a diverging lens, that means the image is closer than the object. So image is closer than the object. And if this is the case, we say the condition nearsighted. Nearsighted. Okay, so for part B, we need to find the um, excuse me. We need to find the image distance um, if we put the object at infinity, because far point is, so when we are trying to find far point, we mean that what's the maximum that an object can be, and where should the image form. So for far point, our object distance should be infinity, and we need to find the image distance from here. Now from equation 23.7 and 23.8, we get the following relation of power and focal length and the various distances. So this is going to be 1 over d0 plus 1 over di. So we see that if we know the power, we can find out the focal length, and since the object distance is given, we can find out the image distance from there. So let's get into that. So as we mentioned that the object distance is going to be infinity, that's that. Then we're trying to find the image distance, and for power it's minus 5.5 diopter. So from here, if we solve for di, we get di. So this guy is 0 because 1 over infinity is 0. So di is going to be 1 divided by, so there's a negative sign, divided by 5.5 diopter, which is nothing but minus 0.182 meters, or minus 18.2 centimeters, right? So one thing we should remember here is the lens is put 2 centimeters in front of our eye, so that means we need to add 2 centimeters with this guy. Now the negative sign is just to show that the object and the image are on the same direction. So just to give you a diagram, if we have a diverging lens and if our eye is around here, it shows that if the object is at infinity, we and if the object is at infinity, so for a diverging lens, the image that is forming should be in front of the diverging lens. So that's why there's a negative sign. But since the distance between the eye and the lens is 2 centimeters, so we need to add 2 centimeters to the absolute value of the image distance. So the far point should be, so the far point should be absolute value of the image distance. That's going to be this plus 2 centimeters, which gives us 20.2 centimeters from I. Thank you.